Please ensure that you are using MRT version 2193 or above. For subsequent processes, if there are no major functional changes, please refer to this tutorial for handling 190. Before using T2 Editor, it is necessary to understand some basic knowledge. The English abbreviation for 190 is T2. It is a secondary translator that only records valid LBA entries of user area. This is also the origin of the name T2 Editor. In the software, 190 is classified as a supermodule. 190 undergoes frequent updates, which can easily result in lots of bad sectors and cause power-on failure. This leads to the next point, which is what we mean by 190 power-on failure. We are referring to busy status or automatic POW reset caused solely by 190 faults. The method to confirm if it is caused by 190 error is as follows. Once 411 is disabled, all modules can be accessed simultaneously. Clearing 190 resolves the issue, which is the 190 power-on failure. Please be sure to watch the firmware unlocking tutorial for specific operations. We will not repeat the demonstration here. Below we will answer the following questions in combination with software operations. Issue 1. Reading problems about Module 190. ID mode reads copy 0 by default. 190 is prone to having a large number of bad sectors. It is recommended to back up copy 1 separately. Copy 1 is usually only readable through track or ABA mode, and reading by track is recommended. If backing up both copies takes very long time, you can try using T2 Editor's command to obtain key LBA data. From SA option retrieves the complete 190 module, not recommended here. Obtain by command retrieves only the LBA data of 190. Green mark indicates normal entries, while yellow indicates entries with a normal structure but empty data. Save the LBA entries as T2 raw data file. In current folder, you can see the 190 and T2 raw data files. Let's look at question 2, the difference between the 190 module and T2 file. T2 raw data file stores the LBA entry data of 190. Comparing them, the size of 190 is 96 megabytes, while the T2 raw data file is only 16 megabytes. This leads us to the next question related to T2 file. Issue 3, difference between save and dump operations. Save is usually used to save the raw, unprocessed LBA entries. Most 190 failures require handling, primarily rebuilding the LBA entries. Therefore, after the rebuilding process, it is necessary to save the process T2 as a dump file. You can see that the process T2 dump file is smaller than the original T2 file. In normal cases, we prioritize backing up the 190 module and obtaining the T2 dump file after processing. If you need to save the original T2 file, you will have these 3 files here. Note, data recovery only requires the T2 dump file. Now let's introduce the TIS mark of the 190 module. In the T2 editor, it is displayed as SIT. Switch back to the 190 module. Search for the plaintext TIS. Starting from the TIS mark, a large amount of data will be recorded. TIS serves to inform the hard drive that the subsequently recorded data pertains to the LBA entries of user area. Of course, even if the mark is missing, it doesn't mean that disk cannot recognize the LBA entries. In the demonstration disk, there is only one TIS mark. Here, we have collected some 190 modules with multiple marks. Let's expand one of them. Select to Site0 and the attempt to retrieve the entries fails. Expand 190 again and select Site1. The entries appear to be normal upon visual inspection. We expand the second 190 module. Select Site0, entries appear to be normal. Expand 190 again and select Site1. The entries still appear to be normal upon visual inspection. Now let's demonstrate the third 190 module. Site0 fails to retrieve the entries. Site1 also fails to retrieve the entries. Selecting Site2, entries appear to be normal. These tests indicate that the actual LBA entries do not always come from Site0. Note, a 190 module with multiple marks may result in more than one T2 file. But the hard drive only recognizes one. Now we need to understand the default expanded entries and searching hidden entries. The faulty 190 modules collected in the folder are just the tip of the iceberg. Let's select one of them to expand. The obtained LBA entries are mostly yellow empty entries. The corresponding user area data is all 00 data. This indicates that the default expanded entries are almost unusable. At this point, it is necessary to enable the Search for All Nodes option to search for hidden entries. Note, red entries indicate entries with a normal structure but corrupted LBA data. Here, we have found a large number of green entries, which indicates a higher chance of data recovery. In the following steps, you only need to try the recommended rebuilding methods to recover potential data. The entries obtained through the TIS mark using default method are called default entries. The entries obtained by enabling the Search for All Nodes option are called searched entries. The searching method is applicable when the LBA entries are damaged and cannot be expanded or when they are expanded into useless entries, as well as in cases of formatting. Next, we need to consider how to handle the default entries and the searched entries. Meanwhile, we will introduce the rules for manually selecting LBA for rebuilding. Version 2193 allows specifying manually selected entries, combined with the rebuilding options to rebuild LBAs. Manually selecting LBA primarily focuses on the entry where LBA 0 is located, and then applies the rebuilding options. The current 190 module has found 2 entries with a starting LBA of 0. Let's assume the LBA 0 entries with ending LBAs of 1662 and 1966049 are both normal. If the default rebuilding option only provides the result for the first entry, then we need to manually select the second LBA 0 entry for rebuilding and verify the data results. This is a 190 LBA chain that consists of many entries. Let's assume that the ending LBA of entry 1, where LBA 0 is located, is 100. In this case, the starting LBA of the correct entry 2 must be 101. This rule also applies to subsequent entries. The key is to ensure that the LBAs of the first and second entries are properly connected. The current 190 displays the searched entries. Step 1. Observe the entries with a starting LBA of 0 and note the different ending LBA values from top to bottom. Step 2. Prioritize the selection of entries marked in green, followed by red. Yellow entries are empty and not considered. According to the above rules, we only have one LBA entry result with an ending LBA of 3769. Note, the Search All Nodes option must be selected for current 190 module. Uncheck the option. The default expanded entries are useless empty entries. Therefore, we must check the option. Earlier, we mentioned that there is only one case for the LBA 0 entry, which is 3769. Let's confirm the second entry. The starting LBA should be 3770, and we found that entry. The mark also shows that it is a normal entry marked in green. We can basically confirm that the LBA 0 entry for 3769 is correct. We use method 1 to rebuild and save it as a dump file. Expand 190 using searching method. Use method 2 to rebuild and save it as a dump file. Expand 190 again using searching method, this time manually selecting the LBA 0 entry for 3769. Use method 1 to rebuild and save it as a dump file. By comparing the sizes, we can determine that the default method 1 and method 2 result in only a small difference in file size. Here, the size of manual plus method 1 is the same as default method 1. This indicates that when the LBA 0 entry obtained from the default rebuilding methods matches the manually selected LBA 0 entry, the results are identical. It's up to you whether you choose method 1 or method 2 for rebuilding. Now, we need to use the T2 dump file, and it's important to use the T2 raw data method for expansion. The dump file is already processed, so there's no need to check the Search for All Nodes option. There are two options on T2 uploading panel. It's recommended to check two options if the 190 module has been cleared before the first T2 write. After the first time, it's not necessary. The log shows that there is valid data of 121 gigabytes. Now, let's test the dump file obtained from method 2. It shows valid data of 117 gigabytes. As we can see, the difference between the two results is minimal. Now, we need to consider the partition expansion results. For the T2 write, the two options are the same as the previous one. Remember to check the option for the first T2 write after clearing the 190 module. We provide the following selection method for the dump file. Priority is given to the dump file with a larger amount of valid data for imaging. If the sizes are close, the partition expansion results need to be verified, and a more complete result is more likely to be correct. The order of obtaining the dump file is as follows. A. Confirm the default entry result, with method 1 preferred. Method 1 and method 2 have minimal differences in most cases, except for a few cases with significant differences. Method 3 can be attempted in cases involving power outage during copy process. B. If the entry cannot be expanded or the entry is almost empty, the search method is the only option. In this case, only method 1 and method 2 can be used. In most cases, there are minimal differences between the two methods, except for a few cases with significant differences. Note, the manual selection method is more versatile, but requires higher individual technical skills and experience. The tutorial will combine different 190 cases to explain whether to use the manual selection method in different situations.